CCI, Crash Course Instrumentation, presents episode number 72. SPICE as a simple answer. Key, words only. Standing credit. Thank you to Tony R. Kupalt and the open source community for the ModL project. Hook, simulators aren't magic. In 4 minutes, we'll use SPICE like a meter with superpowers to check our series parallel math. No graphics, just plain words. Roadmap. We'll explain what SPICE is, what a netlist line means, how to read node voltages and branch currents, why some numbers show up negative, and how to do 2 quick checks before you trust the output. Terms we'll use once in plain English. SPICE. Simulation program with integrated circuit emphasis, a text-based circuit simulator. Netlist. A list of parts. Each line names the part, the nodes it connects to, and the value. Example shape or name node 1, node 2 value. Notice in the connection point. All wires tied together are the same node. SPICE calls the reference node TEM, 0, or TON ground. Av A, B, SPICE's way to say voltage at node A minus voltage at node AB. Sin, passive sign convention. If current enters the positive labeled end of a part, that part absorbs power, acts like a load. If current enters the negative end, it delivers power, acts like a source. Compliance voltage for a current source. The highest voltage the source can create while holding its set current. The tiny circuit in words. Imagine a source feeding resistor A in series with a parallel pair of B and T. Same structure we used in episodes 70 and 71. We'll describe how SPICE would list and report it. What a few netlist lines look like, described, not shown. A resistor line, R11 to 200, reads as, resistor R1 from node 1 to node 2 is 200 ohms. A voltage source line, VBAT1024, reads as, voltage source from node 1 to node 0 is 24 volts, positive at node 1, negative at node 0. A current source line is 300.03, reads as, current source from node 3 to node 0 is 30 milliamps flowing from node 3 toward node 0. If the simulator needs a high voltage to push that current, it raises the node until it hits its compliance limit. How SPICE prints results. Node voltages. A table like V1, V2, V3, measured, relative to node 0, ground. If V1 should 24 and V0, 0, node 1 is at 24 volts. Branch voltages. Printed as VAB, which means voltage at a minus voltage at B. If V311 is negative, it simply means the drop from node 3 to node 1 is the opposite of the order you typed, like swapping meter leads. And currents through sources. Many SPICE flavors print current through independent sources with a sign. By convention, it is the current entering the positive terminal of the source. A negative value can still be fine. It just means the actual direction is opposite that convention. Use SPICE like a meter, then verify. 1. Reduce an amp. Solve by hand first. Episodes 69 to 71. Estimate totals and a few key values. 2. Run an operating point analysis, often called BOT-OP, to get the steady-state node voltages and currents. 3. Compare shared quantities. Series sections must show the same current. Parallel branches must report the same voltage. If not, your node labels or part values are mismatched. 4. Do 2 fast checks. KVL, Kirchhoff's voltage law. Add drops around one loop. They should equal the source rise. KCL, Kirchhoff's current law. At a branching node, currents in must equal currents out. 5. Power sanity. Compute. P equals VXI for each part. Sum of loads should match total source power. If a part shows negative power, it is acting as a source, delivering energy. That is okay if the circuit includes active sources. Common gotchas: floating circuit. If you forget to connect a node to ground, SPICE can't solve absolute voltages. Fix by tying one point to node 0. Wrong polarity in VAB. A minus sign does not mean wrong. It means your order is reversed. Hidden resistances. Measuring current through a source without a defined path can push the model past compliance. Add realistic resistances so the solution makes physical sense. Recap you can say out loud. SPICE is a fast meter. VOIB is a minus B. Node 0 is ground. Series, same current, parallel, same voltage. Check one loop, one node, and total power. If those match, the numbers are trustworthy. Thanks to Tony R. Coupault and the open source community. If this helped, like and subscribe to Crash Course Instrumentation. Next, EAP 73. Loaded dividers and meter loading. In plain English, so your readings match reality.